See, listen. Now we have already know what is backpropagation, right? Backpropagation is nothing but we are backpropagating some sort of information. I mean, in a feed-forward network, there is no backpropagation. In a feed-forward network, we are forwarding the inputs to the outputs. But in backpropagation, what we are going to do? We are propagating the error. What is the error? The difference between actual minus the predicted value. That is the error value. So this error we are going to back propagate through the last layer to the input layer, and then it will again calculate, it will tune the hyperparameters. Which are the hyperparameters? Weights, biases, and different activation functions. So after all this, it will again pass through the feed forward network, then again calculating the error. This error will be reduced than the previous error. Then it will again back propagate to the input layer and gradient calculation. Again we are tuning the weights, biases, etc. This process happens throughout. Okay, this is back propagation. But now we are going to learn about guided back propagation. So what is the difference between back propagation and guided back propagation? See, we know there are different types of activation functions. We already talked about which are the different type of activation functions, right? Which are the different type of activation functions? We are having tanh, sigmoid, and most important is ReLU. So how the ReLU activation functions will be? How the ReLU activation function is? See, ReLU activation. One second, I will draw this. So a ReLU activation functions will be, it will be like, there is no negative values will be there. That is all the negative values it will make 0, and then it is having a this is like a ramp function or a step function. For each and every this function we are having a corresponding like this. For this value we are having a value like this. So this is basically a ReLU activation function. That is, there is no, we are having uh, the values for less than 0. Okay, so ReLU makes that as 0. Less than 0 values are all -1 or zeros, etc. ReLU will make everything 0. So what is this ReLU making 0 means what? So I am scratching this right now. Okay. So, okay. So just I drawn this just to know how your ReLU activation function looks like. So what is the role of activation functions? What will activation functions do? Activation functions will make, if we have passed the image through the, if we have passed the image through this activation functions, in that image, how an image is developed? An image contains full of pixels, that you know, right? It's all of pixels. So pixels means each pixel is having some sort of values. So if that values, which are the values which are less than 0, it will be discarded. That is, such sort of information, ReLU considered such informations are not required, for further process. So this if the image is gone through, or the information which has gone through, passing through the activation function, the values which are less, okay, the values which are less than zeros, or some sort of -1, etc., it will make become zeros. Okay, so that is called as ReLU. So see what it is written: a ReLU function dismisses all negative values and sets them to 0. So in particular, if we are saying we are passing the gradients, we are in each layer we are calculating some sort of gradients, that is d by dx of function. That gradients for all negative values, they are set to the 0. And we have to remember during the backward step, what we need to remember during the backward step? The 0. That is, there is no minus values right now, we are only going to remember the 0 values. So assume we are having a feature map which is fed through a network. At the same time, we are passing it through a ReLU function, and it dismisses all the smaller values and set it to 0. So when doing back propagation, what will happen? We have to remember the layer and the position which is discarded, right? That is flattened, which is discarded. See, for example, if we are taking this process, so this is the activation function of the image. We passed through the ReLU and the red square is set to 0. That means in this image, maybe see, for example, in this image, these particular, which are this 0 and this 0 are maybe the 0 values, and it has to, I mean minus values, and this has to be set to 0, and this has forwarded, and we calculated the error or output, and then we are going to pass. Okay, we are going to pass it through the back propagation. So what will happen? This is again we are considering a convolutional map and then back propagation. In this back propagation, we need to remember these values, right? This 0 values, this 0 values, and this 0 values we need to remember, and we need to discard. So what will happen? We got, after back propagation, we got a saliency map with a full of noisy map. Okay, see, the problem where it arises, see, in this back propagation, this image became full of noisy. So when this become problems, when we want to reconstruct, the original image from this output image, okay, it will be useful, I mean it will be problematic, it's not useful, it will be problematic when we need to reconstruct this image from this noisy image. So what is the process? That process is called as guided backpropagation. We can go for guided backpropagation. Okay, one second. So what will happen? So when deconvolution, now what is deconvolution? Deconvolution means we are going to reconstruct it. Deconvolution now applies what will they apply in the interpretation of gradients? Negative gradients will be suppressed and positive gradients are relevant for the further process, and it has to be kept. So it applies a ReLU in the backward pass also, and it dismisses all the negative values. Okay, yellow squares. So we get a noisy map. This has the yellow map. Okay, these are the negative values. See, these are the negative values. Here -1, -1, -1. This is the ReLU that yellow functions. Okay, so this yellow functions, and after deconvolution, what will happen? We got a noisy map. That is saying here about the dismissed ReLU values. This is due to that we totally forget about the dismissed ReLU values from the forward step. That is this red squares. That is the reason we get a very noisy saliency map here. Saliency map means a feature map here. So guided backpropagation, what will it do? It will combine backpropagation with deconvolution. That is, we are going to apply a ReLU function in both their direction, in the forward pass as well as backward pass. Okay, initially it was only in the forward pass. Now we are going to go for a ReLU function in the reverse mapping also. So what will happen? This is the guided backpropagation. See, this is your without guided backpropagation, and this is with guided backpropagation. So see the difference. This is a very noisy saliency map, but here it is not. At least we could figure out the borders of the figure, right? This is the guided backpropagation. So in this guided backpropagation, what happens? Along with this red squares, that is the dismissed values, we are also going to keep the yellow values of -1, -1, -1. That is the deconvolution. Okay, and the ReLU function. So what will happen? This will happen for, this is the image, this is the original image, and this is the reconstructed guided backpropagation saliency map. So see, we now backpropagate all the way to the inputs. This is the forward pass. In the forward pass, what happens? Like this, it will be 1, 2, and all the negative values will become zeros here. Now, backward pass without guided backpropagation. Okay, backward pass without backpropagation. What happens? -2, -1, -1, -2, -1, -1, and here it will become, this is for after convolution. Okay, so here backward pass with guided backpropagation. Here all values will be 0, but we remained with a 6, 3, all these positive values. See, that is, recall that during forward pass, ReLU activation function allows only positive values to pass and clamps down the negative values. Similarly, during backward pass, there is no gradient passes through the dead ReLU neurons. Dead ReLU neurons means zero zeros. So it cannot pass through that. Those values will again become zero. But in guided backpropagation, what happens? Any negative gradients flowing from the upper layer are also set to zero. There comes, we are getting this zero. That is, upper layer is -2 minus this 3 minus 1. This becomes zero. Okay, this is guided backpropagation.